Chapter 10 focuses on improving visuals through the use of patterns as part of our materials. Instead of just specifying solid colors, I'll be able to use stripes, gradients, rings, and more. The stripe pattern will provide alternating bands of color along the x-axis, using the world position and the modulus operation to determine what band of color it should get. Remember though, since we are using the 3D position in world space to calculate these bands, they won't behave like UVs on the surface of a 3D triangular mesh you might be familiar with in most 3D modeling applications. The stripe-at method will do the hard work of calculating the color based on a point. This will be different for each pattern I create. With pattern colors correct, now it is time to merge it into the lighting calculations. The ambient term is set to 1 in this test, so we don't have to worry about the exact shaded value, just integration. Stripe patterns are being added to my material. This will have to be abstracted away into a general pattern class soon. I test if a pattern exists in the material, and if it does, I query the color and use that in my lighting calculations. To control the pattern, a transform matrix is added, allowing us to translate, rotate, and scale the pattern independent of the object. We'll go from world space to object space and finally into pattern space to perform calculations. This requires a new method called stripe@object, which passes in both the object and the point to transform. After that, stripe@at takes over the actual color value. It's time we generalize things by creating a parent class called pattern, which all patterns will inherit from. It will include the transform matrix and will abstract the stripe@at method, which all child patterns will be required to implement. A test pattern class is created to check if all of my abstraction works. It won't do anything other than convert the point into a color value in pattern space. Now it is time to move to the next pattern type, a gradient. We'll interpolate between two user-defined colors using standard linear interpolation, where we calculate the difference between color A and color B and then add that difference to the first value a based on the fractional component of our point's value. This means by default, our gradient will continue to repeat at each world space integer value. The ring pattern uses the distance method, the Pythagorean theorem, to determine alternating color. The book has this performed only using the x and z dimensions, but we could use the y-coordinate and make these nested spheres of alternating color if desired. Next is the 3D checkerboard pattern, which I also implemented in my other series on Unity volumetric shaders. We're looking for alternating blocks of color in x, y, and z space, and the equation is simply to add the floored value of each coordinate, and then take the modulus, which creates alternating bricks in all three dimensions. Time to put our creation to the test and use it in an actual scene. I copy the previous scene and start placing patterns in my materials. And look at that striped nightmare. This looks like something out of a Tim Burton Beetlejuice nightmare. Now it's time for me to go it alone in the non-guided part of the chapter. First is the radial gradient pattern, where we nest within a radial pattern a gradient instead of a solid color. This one just requires combining the two equations from the ring and gradient to work properly. Alright, that didn't work. After a few more failures, I open up Excel and make sure I'm not crazy in my thinking. Using my equation, I should be getting a repeating gradient value in ring bands, and Excel confirms that. Did you catch that? I accidentally added z to z rather than multiply the two terms. Whoops. Okay, that fixes everything. And now we have these beautiful alternating patterns. Time to complicate things by making patterns nestable. No longer will each pattern use a flat color. Instead, patterns can hold patterns which can hold patterns. To make this work, all color variables will be made as generic pattern types. I'll also need to implement a new pattern called solid color, which will act as a final leaf in our tree of patterns. Eventually, all patterns will terminate using a solid color. Now that things are nested, I'll have multiple levels of pattern transforms. I move the code to transform into pattern space from the pattern at object method to the pattern at method. This way, as I move through my tree of nested patterns, I'll take into account each pattern's individual position, rotation, and scale. This change will be made to every pattern class implemented. Time to create a nested pattern. Here I'm inserting a radial gradient into a checkerboard with a solid color. Well, that's not right. It seems that the pattern can't figure out what to do on our vertical back wall. Randomly, throughout the pattern, it is incorrectly choosing gradient or solid color. This is actually a larger problem than I originally expected, and isn't exactly my fault. It has to do with my double precision. After several tests, I decide to check the errata online, and there I find someone with the same problem. I need to take into account the rounding error by adding my epsilon value, which will push the value into one or the other pattern. Now for the last part of the chapter, adding a blend pattern. There is one other part where it asks to implement Perlin noise, but I'm going to wait till later on that. I already did that in one of my other video series on Python programming and image processing. I do a simple blend where you pass in a t-value, which should be between 0 and 1, to determine how much of each of the patterns should be combined together. But I forget to rotate the second pattern so they line up right on top of one another. 90 degrees later and we have our plaid pattern. That was a fun chapter, adding quite a bit of interesting visuals to our relatively simple scene. I know we could take this much further just looking at how materials are handled in 3D applications, but I'm going to stop here and move into the next chapter, Reflections and Transparency. Let me know how you're doing if you're following along. That decimal imprecision problem took me a bit to figure out, so let me know if anything else has stumped you as well. See you next time, so long and goodbye.